Hello friends, welcome to Learner's Planet. Friends, this is our problem solving session 2 for calculations. I would just like to remind you that do attend these sessions before attending this session, that is types of number, theory of numbers, formula and concepts, and divisibility test. Along with that, you should attend the problem solving session 1 of calculations, so you'll feel more comfortable in this session. Let's begin this session. Now, a 6-digit number is formed by repeating a 3-digit number, for example 256, 256 or 678, 678, etc. Any number of this form is always exactly divisible by. Friends, in our divisibility test session, we have discussed the divisibility test of 7, 11 and 13, all of them. Now, what was that? We have to make a grouping of three digits. So it is 256, 256. Suppose, so I make a group of 3 digits, I make a group of 3 digits. And if the mutual difference is 0, that is 256 minus 256, it is 0, then the number will be divisible by 7, 11, 13, all of them as well. Okay, and the product of 7 and 11 and 13 is 1001. Okay, so whenever you are having a number which is whenever you are having a 6-digit number with first 3 digits and last 3 digits are same or being repeated in this manner, then definitely their mutual difference will be 0. So in all these cases the number will be divisible by 7, 11 and 13, all of them as well, and the product of them is 1001. So the answer to this problem is 1001, since it is divisible by all of them also. Okay friends, now in the next question, which of the following numbers should be added to 11158 to make it exactly divisible by 77? Okay, to make a number divisible by 77, the number should be divisible by 7 and 11 both as well. And further we can apply the divisibility test of 7 and 11 both. Let's go backward, else it will be difficult for us to divide this number by 77. It will take lots of time. So let's go backward. So suppose I add 5 to it. So what I'll be getting is 11158 plus 5 is 63. Okay, now let's check whether it is divisible by 11 or not. 2 and 3, 5, and 6 and 1, 7. So it's not divisible. Similarly, 11158 plus 7, that will give it 11165. Let's check whether it is divisible by by 11 or not. So it's 2 plus 5, 7, and 6 plus 1, 7. So it is divisible by 11. Let's check whether it is divisible by 7 or not. So 165 minus 11, that is 154, and 154 is divisible by 7. Okay, so this number becomes divisible by 77. So the correct answer is 7. It's very easy, friends. Let's do the next problem. Now let's see the next problem. A number when divided by 114 leaves a remainder 21. If the same number is divided by 19, what will be the remainder? Friends, we have discussed the concept of division. That means a number that is dividend is equal to divisor into quotient plus remainder. Okay, so definitely this number can be written as 114 into x. Let x is the quotient plus remainder. Okay, so the given number is actually 114x plus 21. Just a moment. So if 114x plus 21 is divided by 19, what is the remainder? Let's see. Now 114 is multiple of 19, since 19 6 are 114. So from here you won't be getting any remainder, and from this expression 21 by 19 will be getting 2 as the remainder. Okay friends, so 2 is the correct answer. Let's do the next problem. Now in this question, a number when divided by 296 gives a remainder 75. When the same number is divided by 37, and then what will be the remainder? Further we'll be using the same formula, that is dividend is equal to divisor into quotient plus remainder. Okay, let's see in this problem. The quotient is x, divisor is 296, quotient is x, plus remainder will be 30, remainder is 75. Now if this expression is divided by 37, we have to find out remainder. So let's divide. Okay, now 296, we have to see whether it is multiple of 37 or not. So where I'll get 6 at units place if I multiply 7 by 8. So let's see, 37 into 8, it must be 296. 8 sevens are 56, and 24 plus 5. Okay, so this is 8 times. So 296 is multiple of 37. So from this step we are not getting any remainder. Now 75 by 37 will be getting 1 as remainder, since 37 twos are 74. So the final remainder is 1. Okay friends, it's very simple. Now let's see this problem. Here A is been given 0.A1 A1 A1 and B is given as 0.A2 A2 A2, and the series is going till infinity. Here A1 and A2 are multiples of 3, and also A1 and A2 are distinct integers from 0 to 8. So we have to find out the value of A plus B. Friends, we have been given that A1 and A2 are multiples of 3, and as well as these are distinct integers from 0 to 8. That means we have only two choices left for A1 and A2. One of them must be 3 and other of them must be 6. Okay, so A1 and A2, A1 and A2 must be 3 or 6. Maybe A1 is 3, A2 is 6, maybe A1 is 6, A2 is 3. But in any case, it doesn't matter. Now let's solve. So A is equal to 0.A1 bar. Since A1 is repeated, so A is equal to 0.A1 bar. Now 0.A1 bar can be written as A1 by 9. Similarly, B is equal to 0.A2 bar. So it is A2 by 9. Okay. Now A plus B will be A1 plus A2 by 9. Now what A1 plus A2 will be? That is 3 plus 6. Doesn't matter where A1 is 3 or A2 is 6, or A1 is 6, A2 is 3. In both the cases we'll be getting 3 plus 6. So it's 9 by 9, which is 1. So this is the correct answer. This conversion of rational number to fraction, which we have already discussed in our previous sessions. I hope you will be able to recall it. Let's do the next problem. Now in this problem, P is equal to 0.123 and Q is equal to 0.292929. Then which of the following is definitely an integer? Friends, further we have to convert this rational number into a fraction. So P will be 123 by 999, since it is 123, 0.123 bar, and Q is equal to 0.29 bar. So Q will be 29 by 99. We have already discussed the bar is here, the bar is on 3 digits, so we'll be getting 3 nines over here. Here the bar is on 2 digits, so we'll be getting 2 9 over here. Now 123 is also multiple of 3 and 999 is also multiple of 3. So let's cancel it. Let's take 3 as common. Okay, now we have to add P and Q, that is 41 by 333 plus 29 by 99. Now we have to take the LCM of 333 and 99. What 333 is? 3 into 111, or we can say this is 99 is 9 into 11. Okay, so further it is 3 into 3 into 37, and it is 3 into 3 into 11. Then what will be the LCM of these two? LCM of these two will be 3 into 3 into 37 into 11. That is 3 into 3 into 37 into 11. That will be equal to 3663. That means if p plus q is multiplied by 3663, it will be converted to an integer. So this will be the correct choice. Here 3663. So the LCM of 333 and 99, that is 3663, and it will get cancelled from this 3663. Okay friends, so the problem is very simple. Now in this case we have to find out the square root of 8 plus 2 root 15. Then this sort of questions are very common in competitive exams or entrance examinations. Here the aspirants are not expected to find out the square root of this term and then go for a manual calculation. There is a smart method behind this problem. Okay, now we know a plus b whole square. What a plus b whole square is? A square plus 2ab plus b square. Okay, now if you make a comparison of this term to this term, we'll be getting that a square plus b square plus 2ab, that is a square plus b square is 8, and it's 2, and AB is root 15. Okay, now we can think of two numbers. The product of the same should be 15 and their sum should be 8, and we can think of the numbers as 5 and 3. That means a square plus b square is 8. That means a square must be 5 and b square must be 3. That means a is root 5 and b is root 3. So it's root 5 plus root 3 square, that is 5 plus 3 plus 2 root 15, that is 8 plus 2 root 15. That means the square root of this term is root 5 plus root 3. It's very simple if you can think of this logic. Okay, in examination, if the question if the options are based on decimals, suppose the options are like maybe 15, the square root of 15 is around it's just below 4, so it's 4 twos are 8, 8 plus 8 16, so your answer must be just below 4, immediately below 4, so you can choose the same options as well. Okay, let's take another example. In this case, 9 minus 2 root 14, that means a minus b whole square is a square plus b square minus 2ab. Now this a square plus b square must be 9 and ab must be 14. We can think of two numbers. The product of them must be 14 and the sum should be 9. That is 7 and 2. So it's root 7 minus root 2 whole square, since we are having a negative sign over here. So the square root of 9 minus 2 root 14 is root 7 minus root 2. Isn't it so simple? Similarly, in this case, 26 plus 2 root 165, that means a square plus b square plus 2ab. A square plus b square must be 26 and ab must be 165. We can think of two numbers, that is 11 and 15. Their sum is 26 and their product is 165. So it's root 11 plus root 15 whole square. Okay, so the square root of this term will be root 11 plus root 15. Okay friends, now let's do the next problem. Now if in this case, if we wish to make the comparison from a plus b whole square, will not be able to get that since it is 8 over here. So it's 19 plus 2 into 4 root 3. What I write a plus b whole square over here, a square plus b square plus 2ab. Okay, so it is 19 plus 2. Suppose I wish to convert this entire term into ab format, then I have to take this 4 inside the square root. So when it goes inside the square root, it will be 16. That means 16 into 3 48. So it's root 48. Now I have to think of two numbers. The product of them must be 48 and then their sum must be 19. This is actually 16 and 3. So it's 16 16 and I just write here 16 and 3. That means it is root 16 plus root 3 whole square, or you can say 4 plus root 3 whole square. Okay friends, isn't it so simple? Let's do the next problem. Now let's try the next problem. That is, x is a 3-digit number and y is a 3-digit number obtained by reversing the digits of x. If positive value of x minus y, that is modulus of x minus y, is 594, we have to find out the number of pairs in this case. Friends, before we do this problem, I would just like to share an algebra of 2-digit number and a 3-digit number. Let me take a 2-digit number, that is m. Its digits are xy, and a number n, and its digits are yx. That means the reverse of m. Okay. Now any number of 2-digit can be written as 10x plus y format, and similarly here n can be written as 10y plus x format. Now suppose I wish to find out the difference between these two, that is m and n. What I'll be getting is 10x plus y minus 10y minus x. I'll be getting 9 times x minus y. Okay, now what x minus y is the difference between the digits. Okay, that means if I deduct n from m, what I'll be getting is 9 times x minus y. Here x minus y is the difference between the digits. That means I can deduce or I can draw a conclusion that if a number having xy as digits, and if I am having another number which is obtained by reversing the digits of m, then that difference will always be multiple of 9. That difference will always be multiple of 9, and if I divide that difference by 9, I'll be getting the difference between the digits. Okay, I just take some practical example for that. Just a moment. Suppose I have a number 45. So what I'll be getting if I reverse the digit of this number, that is 54, and 54 minus 45 is 9. That means if I reverse the digits of this number, I'll be getting then their mutual difference will be multiple of 9. Okay, and if I divide that difference by 9, that means if I divide this difference by 9, I'll be getting the difference between the digits, as in this case it is 1. Suppose I take another example, 36 and 63. Then 63 minus 36, that is 27, and if I divide 27 by 9, I'll be getting 3, which is the difference between these two digits. Okay, this concept will be very useful in case of applications. Okay, similarly we can let me take one more example. Suppose I have 72. If I reverse the digit, I'll be getting 27. That means 72 minus 27 is 57. It must be 45. And if I divide 45 by 9, I'll be getting 5. That is the difference between the digits. Okay. Similarly, I can expand this rule for 3 digits also. Let's take one example. I have a 3-digit number, that is, suppose xy, that xyz. I take it as p, and I have another 3-digit number that I have obtained from reversing the digits of p, that is zyx. Now p can be written as 100x plus 10y plus z, and q can be written as 100z plus 10y plus x. Now what p minus q will be? It is 99 times x minus z. Okay, that means a 3-digit number p is there, a 3-digit number q is there, which is obtained by reversing the digit of p. And if you find the difference between these two, that difference is always a multiple of 99, and if you divide the difference by 99, you'll be getting the difference between the extreme digits, that means 100 digit and unit digit. Here I am getting the difference between x and z. Okay, so let's take one example for this. Just a moment. Suppose I have a 3-digit number, that is let me take 497. Maybe it is p, and q that I have obtained from the reversing the digits of p, that is 794. Now what p minus q will be? It's 794 minus 497, it is 297. Okay, so 297 can be written as if I divide 297 by 99, what I'll be getting is 3. That is the difference between the extreme digits. Okay friends, so we'll be using the same concept while deal with the problem which we have yet to discuss. Okay friends. Friends, before going to the problem, I just would like to share one more concept with you. Suppose I'm having further m a two-digit number, that is xy, and n a two-digit number yx, which I have obtained from the reversing of digits of m. Okay. Now m can be written as 10x plus y and n can be written as 10y plus x. Now if I wish to find out their addition, in previous case I have found the subtraction, in this case I am finding the addition, that I'll be getting is 11 times x plus y. That means if a number m is there and there is a number n which is obtained by reversing the digits of m, their addition will always be a multiple of 11. Their addition will always be a multiple of 11, and if their addition is divided by 11, we'll be getting the sum of digits. Here in this case, if I divide this by 11, I'll be getting x plus y. So this concept will also be very useful in the case of applications. Okay friends, so let's come back to that particular problem. Now let's try. X is a three-digit number. Suppose x is maybe p q r and y is r q p. Okay, here we have been given that x minus y, the positive value of x minus y is 594. So as we have already discussed, if we divide 594 by 99, we'll be getting the difference between p and r. Here in this case it will be 6. Okay, so we got the difference between extreme digits is 6. So we can make the pairs when the difference between these two digits is 6. Let's try. How can we do that? If I just write p and r over here, if p is 1, r must be 7. If p is 2, r must be 8. If p is 3, r must be 9. So we have three choices for p and r. But the middle number, that is q. Q can have various choices, that is from 0 to 9. Q can be 0, 1, 2, 3, 4, 5, 6, 7, 8 and 9. Okay, so we are having, in fact, for every combination, for 1 and 7, we are having 10 choices. For 2 and 8, we are having 10 choices. Similarly, for 3 and 9, we are having 10 choices. Okay, so many such pairs are possible. So 2, 3, 4 are not the right option. The right option will be more than that. That is none in this case. In many cases, students get confused. They just concentrate upon P and R. They forget to calculate that Q is also there. So they just mark 3, but actually 3 is not the correct answer. Okay friends, I hope you are clear with the problem and with the concept also. Now in this equation, P4 plus Q raised to 4 plus R raised to 4 is equal to S raised to 4 has a solution in integer in which P, Q, R, the values of P, Q and R have been given, and we have to find out the value of S in this case. Friends, this is really a heavy problem. I think lots of calculation is involved in this. Let's begin to do this. Okay, now in the options we see there are various unit digits. So first let's try to find out the unit digit of S. P raised to 4, that is 95800 raised to 4. The unit digit of P raised to 4 will be 0 only. And the unit digit of Q raised to 4, that is 9 raised to 4, the unit digit will be 1. And similarly, unit digit of R raised to 4, that is 0 raised to 4 will be 0 only. Okay, that means from the options, the unit digit of S must be 1. So these options are eliminated. So we are left with these two options. Okay, now definitely we cannot calculate it manually. So let's try to approximate the numbers. Suppose since these numbers are in lakhs, it is 2 lakhs, it is 4 lakh, and this number is below 1 lakh. So let it make 1 lakh. So 1 lakh raised to 4, that means I'm just taking the initial numbers. It will be 1 raised to 4, that is around 1. Similarly, q raised to 4, that is, suppose I approximate 2 lakh, this 2175192 to 3 lakh. Okay, I'm just giving a very high approximation over here. So 3 raised to 4, that is around 81. Then r raised to 4, that is, suppose I take, here I have given a very higher approximation, so I just reduce the approximation over here, or I just approximate this number to lower side. So I just make it 4 lakh. So 4 raised to 4, that will be, that is 16 square, that is 256. What I am getting the sum as 338. Okay. To nullify the effect of approximation, I have approximate q to higher side and r to lower side, and I have reduced r to lower side, but just just a less approximation is there. Only I have deducted 14,560. Okay. Now suppose I go by options. Suppose I take the first digit of this, that is 4 lakh. If 4 lakh raised to 4, that means the value will be around 256. But in this case, if 5 raised to 4, will be getting 625. But our actual answer is, the first 3 digits must be around 338. Students, we are doing the entire problem by approximations. By approximation, that's why do not go much on the numbers. Okay, but the answer cannot be 625. It should be around this number only. So this will be the right choice. Okay, friends. Now in this case, 2 raised to 12 minus 46 is divisible by 3 or 5 or both. Let's do. Suppose I divide this expression by 3. Let me find what is the remainder. So 2 raised to 12 can be written as 3 minus 1 raised to 12 minus 46. Okay. Suppose I divide this by 3. I'll be getting the remainder as minus 1 raised to 12. That is 1. And it is minus 46. So finally I'm getting the remainder as minus 45. But 45 is multiple of 3. That means this expression is multiple of 3. Let's check it for 5 also. So 2 raised to 12 can be written as, it is, we can make it in the multiple of 16. So 2 raised to 4 into 3 minus 46. 2 raised to 4 is 16. So finally this number is 16 raised to 3 minus 46. Now 16 can be written as 15 plus 1 whole cube minus 46. So if I divide this expression by 5, I'll be getting the remainder as 1 cube, that is 1, and this is minus 46. So further I'm getting minus 45. So 45 is also multiple of 5. So this expression is divisible by 3 and 5 both as well. Okay friends, I hope you might have enjoyed the session. We'll see you in the next session. Bye bye.